Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. This is extended physics. Today we are going to attempt a paper 2 of this subject. This paper is a multiple choice paper. Here we have multiple choice questions. There are 40 questions. The time allowed is 45 minutes. The paper we have selected is October-November 2023 2 paper. This paper 2 belongs from the zone 2. So in this video, I'm going to present you the solution of this paper. And why we are doing this? We are doing this especially for our O-level students because we want to provide them more and more MCQ questions, and we want their background of their study to increase because the IGCSE has the questions on momentum, the questions on diffraction, questions on space physics. So these are the main reasons why we are making these videos, because we are providing MCQ papers to our Cambridge O-level students. So let's start today's paper, and here we go. Today's paper is October-November 2023 2 paper. This is IGCSE Physics, and let's start. Okay, so the first question coming up on your screen is, which quantity is a scalar quantity? Acceleration is a vector quantity, force is a vector quantity, time is a scalar quantity. Okay, so the time is basically a scalar quantity, so we can choose it. Okay, so because we were looking for, so this is scalar quantity, d velocity is a vector quantity. So I think C is the choice. C is the right choice. Okay. Then we have the question number 2, and it says a student measures the average speed of a cyclist in a race. You see, whenever you measure average speed of anything, that is always total distance traveled divided by the total time taken. Which quantity must she measure? The total time taken to complete the race and the total distance traveled by the cyclist. So these are the two quantities. In the first A option, is a total time taken to complete the race and the time taken for the cyclist to reach her higher speed. That's wrong. The total time taken to complete the race and the total distance traveled by the cyclist at her higher speed. No, the total distance traveled in the journey. The total time taken to complete the race and the total distance traveled by the cyclist. I think this is the answer. The total time taken to reach her higher speed and the total time of the journey. So C looks the right option, sir. Question number 2, C is the right option. Then we have question number 3. The diagram shows a series of images of a moving object taken at regular intervals. This word is very important because they are taking these photos at regular intervals, means that after equal time intervals. The object is moving from left to right. Which statement describes the motion of the object? Here you can see after equal intervals, they have covered equal distances, the object. But here in equal interval time, the distance traveled is started changing. It has started increasing. So here it is moving with, in this portion, it is moving with the constant speed. Here the speed has started increasing. Okay. So the object travels at a constant speed and then accelerates. C is the right option, sir. First, in the first portion, he was moving with a constant speed. Then his speed started increasing. Means he started accelerating. So I think C is the right option. Question number 3, C is the right option. Yes. Now we are going to the next question. That is question number 4. A plastic ball has a mass of 4 gram and a volume of 20 centimeter cube. So the mass of the ball is 4 gram. The volume of the ball is 20 centimeter cube. There is a crack in the ball's surface. The ball is placed in a bath of water. The water leaks into the ball. without changing the volume of the ball, and eventually the ball sinks. So what happens? There is a crack in the ball. So the water started entering into the ball. So now when the ball is filled with the water, the density of that ball increases. So now that ball starts sinking in the water. The density of the water is 1.0 gram per centimeter cube. That means the density of the ball after the water entered into it has become 1 gram per centimeter cube or more than this. That's why the ball sank. The volume of the ball has not changed. Which mass of the water has entered the ball when the top of the ball is first level with the water surface? These are tricky questions. Let me show you my solution. Okay, here. The mass of the ball plus mass of the water will be equals to density multiply volume. The density of these two things together, when the water has entered into the ball, would be at least 1 gram per centimeter cube. To sink this must be the density of that ball, or more than this. So suppose the density of that ball after the water entered into it has become 1. Now the ball has the mass of the ball and the water in it. So the mass of the water which is in the ball now, suppose its mass is m, and the mass of the empty ball is 4 gram. The density has become 1, and the volume is still 20 centimeter cube. It's a tricky question. So the mass m plus 4.0 will be equals to 20 gram. So m will be equals to 20 minus 4, and m will be equals to 16 gram. So the water which entered into the ball, its mass is 16 gram. So the water which entered into the ball, its mass is 16 gram. It's a little tricky question. I hope 16 grams. So let's check. 16 gram means B is the choice. So I think question number 4, B is the choice. Yes, that is right. This is how we found it. I hope you understand this concept. It's a little tricky question. So now question number 5. A satellite orbits the Earth at constant speed in a circular orbit. So the satellite is moving at a constant speed, but it is moving in a circular orbit. Whenever you are moving in a circular orbit, your direction of motion is continuously changing. So that means your velocity is changing. That means you are accelerating, although your speed is constant. So you will have a resultant force. And that resultant force is always directed towards the center of that circular orbit. So because the orbit is circulating around the Earth, so the resultant force acting on it will be directed towards the center of the Earth. So the resultant force on the satellite is 0. That is wrong. The resultant force on the satellite is towards the Earth. That is true. This sentence is 100% true. The resultant force on the satellite is away from the Earth. That's wrong. The resultant force on the satellite is in the direction of its motion. That is wrong. So B is the choice. Question number 5, B is the right choice, sir. Question number 6. The diagram shows 4 identical objects. Each object is acted on by only the forces shown. Which diagram shows an object in equilibrium? You see, here you can see 20 Newton force is acting upward, 20 Newton force is acting downward, but this is not in equilibrium. The reason is because these two forces, they have the same line of action. So there a resultant force of 10 Newton will be acting downward. So this and this resultant force will cause this object A to rotate. It is producing a couple. We call this couple. So this body will rotate. So these forces are not balanced. These forces are acting upward with a 20 Newton. This force is acting downward with a 10 Newton. So there is a 10 Newton resultant force in the upward direction. So this body will move. This is not equilibrium. Here, left and right forces are balanced, but this upward force is not balanced by any force in the downward direction. So it's not in equilibrium. If you look at here, 20 Newton is acting upward, 20 Newton is acting downward. So this is trying to produce a anti-clockwise. This is trying to produce a clockwise. So this will be balanced. So actually the thing which will be balanced in equilibrium, that will be this D option. Question number 6, D is the option, sir. That is right answer, sir. Next question is question number 7. He says, a resultant force F accelerates a car of mass M along a straight horizontal road from rest to a speed v in the time t, giving its momentum p. Which pair of relationships for this situation is correct? Okay. Now, you know the momentum p, that is mass multiply velocity. And the force will be momentum multiply time. So simply B is the right option, sir, because the momentum is mass multiply velocity and the force is momentum multiply time. Momentum multiply, uh, no, uh, wait, wait. Momentum is, wait a minute. There is, okay. So I made a mistake here. You see, the momentum is mass multiply velocity, but the momentum is also equals to force multiply time. That is force multiply time. That is called impulse. Okay. So the real answer is C. Okay. C is the right answer. Let's check. Question number 7. C is the right answer. Once again, I'm telling you that I just made a mistake and the option is C. The momentum is mass multiply velocity and the momentum is force multiply time. So I made a mistake. Now the answer is C. I first of all, I said B. That is wrong. Okay, sorry for that. Okay, now we are going to the next question. And the next question is question number 8. He says the diagram here shows part of a roller coaster ride with the car at different positions. The car runs freely down from the position X to position Y and up the hill on the other side. What happens to the energy in the kinetic store and the gravitational potential store of the car as it moves from the position X to the position Y? Okay, here, because it's on a height, it will have gravitational potential energy, and that when it will come down, that gravitational potential energy will convert into the kinetic energy. And at this point, it will have kinetic energy. So as it is going from X to Y, its gravitational potential energy is decreasing and its kinetic energy is increasing. So let's see what happens. Kinetic energy in the kinetic store, that is increasing, and the energy in the gravitational potential store, that is decreasing. So I think C is the right option because the kinetic energy is gradually increasing, gravitational potential energy is gradually decreasing. So question number 8, C is the option. Yes, sir, that is the right answer. So we are, let me reduce the size so you can see the whole question. Okay, now I hope you can see the whole question together. C is the option. Question number 9, which is a very tricky question. And it says, a box is initially at rest at the top of a rough slope. The box slides down the slope. The weight of the box is 20 Newton. The slope is 4 meter long and 2 meter high. The box does 10 joule of work against the friction as it slides down the slope. What is the speed of the box as it reaches the bottom of the slope? So at the top, it will have here, it will have the gravitational potential energy. And when it will reach when it is almost at the end, that gravitational potential energy will be converted into the kinetic energy. And during this, the gravitational potential energy is lost, and during this process, the kinetic energy is gained. But when they were coming down that ramp, they have to do work against the friction. So when you do work against the friction, that energy converts into heat. So this much energy will be converted into heat. So the energy which is converted into heat, that is lost to the surrounding. So what happens? That is a loss of energy. So now what we'll try to understand this equation. The loss in the gravitational and potential energy will be equals to the work against the friction plus the gain in the kinetic energy. This equation is very important. Okay, so let me show you. I have done this. Okay, so what I am saying is that the loss in the gravitational potential energy, that will be mgh, that will be weight multiply its height, the vertical height, that is 20 into 2, and that will be 40 joule. And loss in the gravitational potential energy as you come down, it will be equals to the work done against the friction plus the gain in the kinetic energy. Now, the loss in the gravitational potential energy is 40 joules, and the work done against the friction is 10 joules, plus the kinetic energy will be 1 by 2 mv square. So 40 minus 10, that will be 30. 30 is equals to 1 by 2 mv square. This 2 will go to the other side, it will multiply. So you will have 60 equals to mv square. The mass of that object will be weight divided by the g value, that is 9.8. So the in the place of mass, I will write 20 divided by 9.8 into v square. So the v square will be equals to 60 multiplied 9.8 divided by 20, and the v square will be 29.4. Take square root on both the sides, so v will be equals to 5.4 meter per second. 5.4 meter per second. So I think A is the right option, sir. Question number 9A is the option. Question number 9A is the right option. Question number 9A is the right option, sir. Okay, so let me show you the solution again. So, and let me reduce the size so you can see the whole answer together. So, my answer is 5.4. Hopefully, you understand how this is done. And the loss in the gravitational potential energy is equals to the work done against the friction plus the gain in the kinetic energy. This is a very important equation. Okay. Now we are going to the next question. That is question number 10 showing up on your screen. He says, an electric car is charged overnight. In 8 hours, 180 million joules, megajoules, you can say, of energy is transferred. What is the power of the charger? You know, the power is the energy divided by the time, and the energy here is megajoules. So I will convert them into joules, and then you see, it will be like this. 180 exposed 6 joules. Megajoule, I converted it into the joules. The time is 8 hours, but the time must be taken in seconds. So 8 multiplied 3600, because in 1 hour there are 3600 seconds. So now you will have 28,800 seconds. Power is equals to energy divided by time. So 180 exposed 6 divided by 28,800, and that is 6,250 watts. Now, because the answers given there are in kilowatts, so I will divide a watt with the 1000, and it will be converted into kilowatts. So it will be 6.25, which is approximately 6.3 kilowatt. 6.3 kilowatt. 6.3 kilowatt. So this is how this is solved. So let me 6.3 kilowatt. So I think A is the answer. Let's check question number 10. A is the right answer, sir. So this is how it is solved. Hopefully you understand. So question number 11, an object is is a depth h below the surface of a liquid. The pressure due to the liquid at this depth is P. The gravitational field strength is G. What is the density rho of that liquid? Okay. So, the pressure of a liquid is rho GH. So the density which is represented with the rho, that will be equals to the pressure divided by GH. Pressure divided by GH. Pressure divided by GH. So the density will be equals to this. So D is the right option, sir. Question number 11, D is the right option. Okay, let me show you again. This is how I have found it. Then we have question number 12. Brownian motion is the random motion of particles. In which states of matter is Brownian motion observed? Brownian motion is observed in the liquid and the gaseous state. Liquid and the gaseous state. So, yeah, B is the right option, sir. Gases and liquid only. Question number 12, B is the option. That's right. Okay. Now we have question number 13. It's a very conceptual question. The volume of a fixed mass of a gas is varied. The temperature remains constant. So this is important. The temperature remains constant. Okay. The graph shows how the pressure P of the gas varies with the volume V. The pressure and the volume, they are inversely proportional to each other. So if you draw a graph between pressure and the volume, the graph will be inversely proportional. Graphs are something like this. Okay. But if you draw a graph between P and the reciprocal of the 1 by of the V, I mean, then the graph will be like this. Okay. So I think D is the choice. This you have studied where? If you have done in your mathematics graphs of the inversely proportional, for example, if the P and V are inversely proportional to each other, then the graph is of this shape. But if you draw a graph between P and the reciprocal of the V, then the P and the 1 by V are directly proportional to each other. So then the graph is like this. So D is the choice. Very tricky, very conceptual. Question number 13. D is the right answer, sir. I hope you understand. Question number 14. Question 14. Liquid evaporates from a beaker. What happens to the temperature of the remaining liquid, and how does the temperature change affect the rate of evaporation? So when the water evaporates, the remaining liquid its average kinetic energy will decrease, its temperature will decrease. So the temperature of that remaining liquid will decrease. And when the temperature drops, the rate of evaporation also decreases. So the temperature decreases and the rate of evaporation will also decrease. So I think A is the option. Question number 14, A is the option, sir. That is right. I hope you understand this concept. Okay, then we have question number 15. He says, thermal energy, delta E, is supplied to an object of mass M, which does not change its state during the heating process. The temperature of the object rises by delta T. The change in the temperature is delta T. What is the specific heat capacity of the object? Okay, very easy, very simple. This is easy one. Question number 15 we are talking about. Heat is equals to mc delta T. That's the famous formula when the temperature changes. So the heat is equals to mc delta T. Heat is delta E, okay, so equals to mc delta T. So we want that C to be alone, which is specific heat capacity. So the M and delta T will go on the other side and divide. So the C will be equals to delta E divided by M divided by delta T. So delta E divided by M divided by delta T. So I think A looks the right answer, sir. Question number 15. A is the right answer, sir. Question number 15, A is the right answer. Okay. So we are done with question 14, 15. Okay, now we are on question number 16. A room is heated by a radiator. The diagram X and Y show two possible circulations of hot air which heat the room. Okay. In the diagram X, you can see here we have a radiator. The air is rising from here, and from the other side of the room, it's going down. Okay. Here on the radiator here, they have shown in the diagram Y the air is going like this and rising, and from here it is coming down. Which diagram and reason explains the heating of the room by convection? So the best diagram is this one. And the reason is the air here will become hot and it will become less dense and that air will rise. So at the point in the diagram X, the air density decreases when air is heated. That is right. Air density increases when air is heated. Air density decreases when air is heated. Air density decreases when the air is heated. That is right. So the X diagram is the right diagram. So I think A is the option. Diagram X is right. This Y diagram is wrong because the radiator gives out heat. So it's not possible that on top of it, the air is coming down. So question number 17. A student writes down some facts about two transverse waves. Wave 1 has a frequency f and a velocity v. Wave 2 has 4 times the frequency of the wavelength wave 1 and is traveling at a velocity of 2v. What is the wavelength of the wave 2 in terms of f and v? Very simple. It's a straightforward question. So let's check. Okay, this is question number 17. Okay, so question number 17, wave 1, v is equals to f lambda. So the wavelength is v by f. For wave 2, the velocity, this is the wave equation that velocity is equals to frequency multiply wavelength. Its velocity is 2v and its frequency is 4f and its wavelength is question. So wavelength will be equals to 2v divided by 4f. So it will be 1 by 2 of the v by f. So it's v by 2f. V divided by 2f. V divided by 2f. V divided by 2f. V divided by 2f. So I think D is the right option, sir. Question number 17. D is the right. D is the right option, sir. This is how this is done. This is question number 17. Okay. And our option is right. Now we are on question 18. Straight wavefronts on the surface of a ripple tank approach a gap in a barrier. The diagram shows how the wavefronts change shape as they pass through the gap. What is the name of this effect? So when the wavefronts pass through that gap, they convert into circular wavefronts. Before passing through that gap, they were straight line wavefronts. After passing through that gap, they have become circular. This process is called diffraction. So what is the name of this effect? This is called diffraction. So A is the option, sir. Question number 18, A is the right option. Question number 19, he says light travels from air into glass. What is the relationship between the refractive index N of the glass, the angle of incidence I, and the angle of refraction R? It is N is equals to sine I divided by sine R. Sine I by the sine R. That angle is put in the numerator, which is in the rare medium. In this case, because the light was entering from air into the glass, so the angle of incidence was in the air, which is rare as compared to the glass, which is dense. So in this formula, n is equals to sine I by sine r. I told you this is the rule that upstairs we put that angle which is in the rare medium. So sine I by sine r. So question number 19, I think C is the option, sir. C is the right option. Okay, which diagram shows the image correctly formed by reflection? So in the reflection, the diagram flips, okay? So very easily, all the diagrams are wrong. This D is the right option, sir. This is the exact image in the mirror. D is the right option. Question number 20. D is the right option, sir. You see, this next question is question number 21. A student passes parallel rays of light through 4 different converging lenses. He measures the distance x and the distance y for each experiment. You see, this is a very simple rule. The parallel rays, the rays which are parallel to the principal axis, when they pass through the convex lens, they all focus on the principal focus. The distance between the optical center and the principal focus is focal length. So in this diagram, x is the distance between these two parallel rays which are parallel to the principal axis. Y is the focal length. That is the rule. Once again, I am telling you, the rays which are parallel to the principal axis after passing through the convex lens focus on the principal focus. The distance between the principal focus and the optical center of the lens is called the focal length. So Y is basically representing the focal length. So which lens has the longest focal length? Okay, so clearly which one has the longest focal length? This one. The X has nothing to do with this, okay? So it is just to confuse you. 3.1 focal length, Y value where? So I think 21, B is the option, sir. That is right, sir. Hopefully you understand. It's a little tricky question. The frequency, question number 22. The frequency of the microwaves used in a microwave oven is 2400 megahertz. What is the wavelength of these microwaves? You know, we know the speed of the microwaves. The speed of the microwave is 3 expo 8 meter per second. The frequency of the microwaves is given 2400 megahertz. And we want to calculate the wavelength. Very easy, simple. This is a simple question. The only trick here is that the frequency is 2400 megahertz. It should be hertz. So I will write is 2400 expo 6 hertz. The speed of that you have to remember 3 expo 8 meter per second. V is equals to F lambda. So lambda will be equals to V divided by F. So it will be 3 expo 8 meter per second divided by 2400 expo 6 hertz. When you do this calculation on your calculator, you will get the answer 0.125 meter. 0.125 meter. I think A is the option. Question number 22, A is the right option, sir. This is how this is done. Question number 23. He says, which row gives typical values for the speed of sound in a solid and in a gas? So the speed of the sound in the solids is in thousands of meters per second. And in the gas, it is like 300. So clearly, D is the option. It's just a fact and it's very easy. Question number 23, D is the right option, sir. Question number 24, a hard magnetic material can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary magnet. Which row shows whether iron, steel are hard or soft magnetic materials? You know, iron is a soft magnetic material and it is used to make temporary magnets, whereas the steel is a hard magnetic material and it is used to make permanent magnets. So the iron is a soft magnetic material and steel is a hard magnetic material. Soft magnetic material means that it can be easily demagnetized. Hard magnetic material means that it keeps its magnetic properties, it retains its magnetic properties for a very long time. So steel, hard magnetic material, iron, soft magnetic material. So I think C is the option for question number 24. Yes, sir, C is the right option. Okay. Now, question number 25. He says, a power source is connected to a resistor XY. Which directions are the conventional current? The conventional current will be going from positive to negative. So this is the direction for the conventional current. But for the electron flow, which directions are the conventional current and the flow of free electrons through the resistor? The free electrons will be flowing from the negative towards the positive. This is free electrons. Okay. So, conventional current is from Y to X, and the free electron is from X to Y. So it looks C is the right option. It looks C is the right option. Let's check again. Okay. For the conventional current, it will be, oh, I made a mistake. For conventional current, it will be going from Y to X. So I made a mistake. How can I delete it? Okay, so anyway, I'm not able to delete it. This is wrong, sir. This is not the option. Okay. The conventional current is going from positive to negative, so it's going from Y to X. So D is the right option. Okay. D is the right option. This is also not the right option. I think it's very hot. Okay. Conventional current is going from Y to X. Okay. And the electron flow is going from X to Y. So the right option is the C. This is wrong, sir. The right option is C. Sorry. The conventional current is going from Y to X. Okay. And the electron flow is going from X to Y. So C is the right option. So the option here is what? C. C. Question number. Which question is this? This is question number. I think I have to click here. This is not moving. Yeah, this is question number. I don't know why this is not moving. Okay. This is question number 25. C is the option, sir. Sorry for, I just made a mistake. Okay, so the C is the question number 25. C is the right option, sir. Oof. Question number 26. Question number 26 is which unit is used to measure electromotive force EMF? Electromotive force is measured in volt. Okay, that is very simple. It's a fact. It is measured in volt. Okay, so I think C is the option. Question number 26, C is the right option, sir. Okay, so then we are going down. I don't know why it's not going down. Question number 27. Question number 27. Okay, the graph shows a current voltage characteristic of a filament lamp. And here the current is on the y-axis and the voltage is on the x-axis. You know, the gradient, the slope here, that is equals to, the slope here is basically equals to I by R. And you know the I by R, sorry, I said I by R, it is I by V. So this is basically reciprocal of the resistance. Okay. So whatever is happening to the slope, the opposite is happening with the resistance. Okay. The slope here is I by V, which is 1 by R. So if you can see here, the gradient of this graph is gradually decreasing. So if the gradient of this graph is gradually decreasing, opposite is happening with the resistance. The resistance is gradually increasing. So he says, which statement describes how the resistance of a lamp changes as the voltage increases? As the voltage is increasing, the gradient of this graph is decreasing. So the opposite is happening with the resistance. It means the resistance is gradually increasing. So the resistance increases. Okay. The resistance is increasing. So I think question number 27, C is the option, which is right option, sir. Question number. So I think it's right. Question number 27, C is the option. Okay, so now we are going to the next part. And in the next part, okay, that was question number 27. Now we are on question number 28. He says the diagram, in the diagram, the rod R is suspended from an insulating thread. Okay. When the positively charged rod Q is brought close to rod R moves away from the rod Q. Which conclusion can be made from this observation? You see, the R has been repelled. Q is positively charged. So why the R will be repelled if the R is also positively charged? Okay. So R must be positively charged, I think. So the R is positively charged. So I think it's the B is the answer. So let's check. This is question number 28. Question number 28, B is the right answer, sir. B is the right answer. So now we are going to next question. That is question number 29. In the question number 29, they say, the circuit diagram shows a circuit used to run a DC motor from an AC supply. Which graph shows the current in the motor? Okay, so when the current will come from this direction, it will let it go. And from here, it will go back. So the current has basically gone in this direction. Now remember this thing, okay? Now, when the current, because this is it's alternating current. Now, when the current will come from this direction, it cannot go in this way, okay? So it will go this way, then this way, and okay. So now the current is still going in this direction. And then from here, it will go back. Okay. No. From here, it will come here, here, and then it will go from here, 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 and it will go back. So whether the current flows in this direction or the current flows in this direction, because the supply is alternating, the current which is flowing through the motor, that is always in this direction. I try to show you with the red and the green. So because the motor is a DC motor. So this is the benefit of these diodes. You see, if when the current is coming from here, it goes from here and it goes out from there. But if the current tries to come from here, because this diode will be in the backward bias, so it will not let it pass through. So this is the benefit of this circuit. So these diodes, what they are doing, they are converting the alternating current into DC current. Okay. And the full wave rectification is done. So the full wave rectification is done. That is here. D is the option, sir. This is full wave rectification of the alternating current into the DC current. Question number 29. I think D is the option, which is the right option, sir. Now, we are on the question number 30. It says, okay, question number 30, it says the circuit shown can be completed by inserting components at X and at Y. The completed circuit is a potential divider in which the potential difference across the component Y increases when the temperature increases. Okay. So when the temperature increases, this reading increases. So that means here you will attach something whose resistance decreases when the temperature increases. So here I think you have to attach a thermistor. Okay. So here we will attach a thermistor, and here you will add a simple resistor. So now you will see what will happen. When the temperature will increase, the resistance of the thermistor will decrease. So the voltage coming from back, they are still the same. Okay. So the voltage drop here will decrease and the voltage drop here will increase. So we have to connect a thermistor at X and at Y a simple resistor. So what is the answer? At X you will have to connect a thermistor and at Y you will have to connect a fixed resistor. So I think D is the option, sir. Question number 30, I think D is the option. Question number 30, D is the right option, sir. Okay, so we are going to the next part. He says, question number 31. A piece of soft iron XY has a coil of wire wound around it. Okay. The north pole of a bar magnet is pulled away from the end X, which causes an induced current in the coil. Okay. So when this north pole is going away, automatically the current will be induced here, and that current will be such that here a south will be formed and here a north will be formed automatically. Why a south here? To stop this going away north. That's the Lenz's law. Okay, now what they say? They say that the magnet is now, what they have done, now the magnet is now turned around, so the north pole is on the left. Now what they have brought it here, and what they are doing, they have placed the magnet here, and now its north is basically is on the left, and here you have that south. This is what they are saying, and they are bringing it like this. Okay. The magnet is not turned around so that the north pole is on the left. It is taken to the other end of the soft iron and the north pole is pushed towards the end Y. A new current is induced in the coil. Which statement is correct? Okay. When this north will try to come here, so on this side, to stop this approaching north, automatically a north will be induced here and a south will be induced here. So to stop this, so you see the current induced in this coil is still the same. This is a tricky question. He says, uh, which statement is correct? A new induced current is in the opposite direction and causes the soft iron to attract the north pole. No. The new induced current is in the opposite direction and causes the soft iron to repel the north pole. No. The new induced current is in the same direction and causes the soft iron to attract the north pole. No, not attract. The new induced current is in the same direction and causes the soft iron to repel the north pole. Yes. The north pole which is approaching, it should be repelled. That is Lenz's law. So D is the option, sir. Let's check first. Let's first of all reduce the size so you can see the whole thing together. This is question number 31, very tricky one. D is the option. Question number 31, D is the right option, sir. A little tricky. Okay. Again, this question has a huge size. Okay. The diagram shows a wire in the magnetic field between two poles of a magnet. The current in the wire repeatedly changes between a constant value in one direction and a constant value in the opposite direction as shown in the figure. So remember, this is a current carrying coil placed in a magnetic field. So if you have a current carrying coil placed in a magnetic field, it experiences a force. Whether the current is constant, whether the current is changing, whether the current is downward, whether the current is upward, it experiences a force. Okay. He says, what is the effect on the wire? The voltage, the current they are providing through passing through the wire is positive, then all of a sudden it goes negative, all of a sudden it becomes positive. So the force on the wire alternates between one direction and the opposite direction. Yes, that is true. When the direction of the current will change, the direction of the force acting on it will also change. The force on the wire alternate between one direction and the opposite direction. Yes, that is true. The force on the wire is constant in size and direction. No, because the direction of the current is changing. That's why the direction of the force must change. There is no force acting on the wire at any time. That is wrong. It's a current carrying coil placed in a magnetic field. It experiences a force. D, there is only a force on the wire when the current reverses. No. The force is all the time present there. Okay. So A is the choice. The force on the wire alternates between one direction and the opposite direction because the direction of the current is changing. That's why this is changing. So A is the option, sir. We think that question number 32, A is the option. Okay. Now we are going to the next part. This is question number 33. It says a transformer has NP turns on its primary coil and NS turns on its secondary coil. The voltage across the primary coil is Vp and the voltage across the secondary coil is Vs. What is the relationship between these four quantities? It's very simple. Vp by Vs is equals to Np by Ns. It's a famous formula. So B is the option, sir. Question number 33, B is the option. Yeah, that's true. Okay. Question number 34. A magnesium ion has a double positive charge. Double positive charge means it has lost two electrons. And a chloride ion has a single negative charge. It means it has gained an electron. Which statement is correct? A chlorine atom gains an electron to form the chloride ion. Okay. So that's right. A chlorine atom loses a proton. No, proton is never lost. A magnesium atom loses an electron to form magnesium ion. No, it's positive too. so it has lost 2 electrons. A magnesium atom gains 2 electrons? No, not gained. So 34A is the option, sir. Question number 34A is the right option. Then we have question number 35. Which row correctly describes an example of radioactive decay? So in the radioactive decay, the original nucleus is unstable. And when it converts alpha or beta, then a new element is formed. It changes into a new daughter element. Okay, so the original nucleus is unstable, and if it gives out alpha, it will change of element. Okay, change of element will take place. Okay, so this is the best statement. You see, beta is also given here, but here he says no change of element. No, when alpha or beta is given out, the parent nucleus changes into a daughter nucleus, which is of a different element. Okay. Question number 35, B choice. Yes, that's right. Question number 35, B is the right option, sir. Question number 36. He says a radioactive isotope of sodium has a half-life of 15 hours. The table gives data for an experiment to show how the rate of decay of the isotope varies with time. The background count rate has not been subtracted from these data. Okay. What is the background radiation count rate? Okay. So because the half-life is 15 hours, sorry, because the half-life is 15 hours, so in 30 hours, the 2 half-lives would have passed. One half-life is 15 hours. So after 30 hours, it means 2 half-lives have passed. When 1 half-life passes, the thing remained is 1/2. When 2 half-lives have passes, the thing, that original isotope, how much it has left is that is equals to 1/4 of its original value. Okay, or in other words, you can say the count rate or drop. Sorry, it was I was writing 4. Sorry, I was writing 4. Oh my God, I was trying to write 4 here. Okay, so after 2 half-lives, the count rate will become 1/4. Okay, but the problem is that they have not subtracted the background radiation from these two. Okay, so what we are going to do, we are going to show you how this is done. A very different kind of question. Okay, now let the background count, background radiation is X. So after 2 half-lives, the original radiation will have. Okay, so first of all, at 0 time, the radiation was 400. So from there, subtract the background, which is X. So 400 minus X. So after 2 half-lives, it will become half. So 400 minus X, the whole thing divided by 4. That will be equals to, after 30 hours, they say the count rate is 115. So from it, subtract the background. So this is. So this 4 will go on the other side, multiply there. So 400 minus X will be equals to 460 minus 4X. So this 4X will come on this side. So minus X plus 4X is equals to 460 minus 400. So 3X is equals to 60. So X will be equals to 60 divided by 3. And that is 20. Does that mean the background count rate is 20 counts per second, or 20 counts per. So 20 is my answer. 20. So the background is 20 counts per second. Okay. So C is the option. Question number this. C is the option, sir. So question number 36, I think we were doing. The C is the option. This is how this is done. Question number 36, C is the right option, sir. Okay. Now we are going to the next question. That is question number 37. He says, what happens in the process of nuclear fission? In the nuclear fission, a neutron is bombarded on a larger nucleus, And what happens? That splits that nucleus into daughter nucleus. So the nucleus of an atom splits. So C is the right option, sir. I think question number 37, C is the option. Yes, the question number 37, C is the right option, sir. Okay, now question number 38. He says the time taken for the Earth to orbit the Sun is approximately 365 days. The average radius of the Earth's orbit around the Sun is 1.5 expo 8 kilometer. What is the average orbital speed of the Earth? The average orbital speed is 2 pi r divided by t. 2 pi r divided by t. Okay. So let me check if I have done this. That is 2 pi r divided by t. And because the radius is given in kilometers, I will convert into meters. And because the time is given in days, I will convert that into seconds. So the orbital speed will be equals to 2 multiply pi multiply 1.5 expo 8 multiply expo 3 divided by 365 divided by 24 divided by 3600. So when you do this in your calculator, you will get 29,885.7 meter per second. That is approximately 30,000 meter per second, which is 3 expo 4 meter per second. 3 expo 4 meter per second. 3 expo 4 meter per second. So I think 38C is the option. Question number 38, C is the option, sir. 38. C is the right option. Question number 38, C is the right option. Okay. So question number 38, C is the right option. So where is that? Okay, now we are going to do question number 39. He says, the sun transfers energy to the earth through electromagnetic radiation. What are the two of the parts of the electromagnetic spectrum to which the most of the energy belongs? It is infrared, it's a fact, infrared and the visible light. Straightforward. Infrared and the visible lights are very famous fact, frequently asked in papers. 39, I think B is the option, sir. B is the right option. Okay, now we are going to the last part. This is question number 40. How does the sun produce its energy? You see, in the sun, the process of fusion is taking place, in which the smaller nuclei of the hydrogen and hydrogen, they come, they fuse into each other, and they create helium. Okay, so by the fusion of the hydrogen, this is what is happening on the sun. For question number 40, D is the option, sir. Question number 40, D is the right option. So hopefully you understand. So we are done with this paper. So my dear students, we have completed this paper. This is Cambridge IGCSE extended physics, and the code of the subject is 0625. The paper today we have done in this video is October-November 2023 2 paper. In this video, it was about MCQs. So I have tried to explain you all the concepts, procedures to the best of my knowledge and to the best of my abilities. During making these videos, 2 times I made a mistake. I rectified there, and sorry for that. This is possible. We are human, and it's possible that we might make a mistake. That's why we always have our marking scheme with us to check what the Cambridge says. Okay, so thank you very much for watching this video. If you like this video, please share the link of this video with your friends, with your class fellows, with your junior students, with your teachers. Share the link of this video on your WhatsApp groups, in your Facebook, on your Twitter, on your Instagram, on your TikTok, wherever it is possible. When you do this, you help me to promote my channel. So thank you very much, everyone. Our main aim is to make the life of our students and their parents' life and their teachers' lives little easier. So thank you very much. Have a good day. God bless you all.